Okay, hi everyone. This week we're delighted to be joined by Mohammad Hashim Ibrahimkhil, and his supervisor is Johnson, and he's in his second year of his PhD. His topic is real-time construction progress monitoring through robotic field mapping. And from what I've seen before, it looks to be very exciting. So I'll hand over to you, Mohammad.
Yeah, thank you. First of all, I wanted to thank everybody that you attended my presentation. And as you mentioned, my research topic is related to real-time construction progress monitoring. And we are using some handheld and mobile scanners for collecting the data. I'm a second year PhD student here at UNSW and working under supervision of Dr. Shen. So as we mentioned, regarding the research work is regarding the progress monitoring. And we know that one in construction industry, usually it has a low productivity rate compared to other industries. So there are different and several reasons behind that one. And one of the field which influence over that low productivity construction industry, that is progress monitoring. So this progress monitoring is, you say, this very important for to measure the contract as per to work as per the contract, and also that will help us for decision making in even as we mentioned, for improving productivity of the industry. But if we look back to the traditional progress monitoring, there are different problems associated with that traditional construction progress monitoring, because usually the data from construction site are collected manually. That is like and they visualize that one and observe the sites, and they collect the data. So if that's the case, then usually that is time consuming. It needs a lot of time to collect the data. And also since the laborers and other engineers, they will go to for collecting data from construction site, then that will be error prone, and also it will be biased, because contractors, they will always try to have to show that lots of work has done already on the site, but on the other side, client will claim that the work is not as much which was claimed by the contractor. So that's why usually there also sometimes will be claims between the two sides. And that traditional procedure is also like infrequent and not in real time, which that will also again help on the process of the work and finally on the completion of the successfully completion of the project. So with these problems, usually the construction projects will be delayed, and there will be cost overruns, because this is time consuming that method, and they are not in real time. And also there will be low construction quality because of the procedures, and also there will be sometime, as I mentioned before, disputes among client and contractors. So because of that one, the research community has already started to use different reality capture techniques to collect data from construction site and use that data in progress monitoring. So among them are one is image-based or photogrammetry method. And photogrammetry method, there will be images will be used in the processing, and the image will be converted back to a 3D model. And as per that one, they will show the progress. On the other side, there are different types of laser scanners. They're also used for collecting data from construction site. And the data which is collected by laser scanners, that will be in the shape of, in the format of point clouds. And usually terrestrial laser scanners will be used for collecting the data from the sites. In addition to these two capture techniques, there are some others also. For example, global positioning system or GPS, radio frequency identification, and also ultra wideband. Usually, the remaining three are used for tracking the resources or for movement of the resources. But for cast-in-place activities like for the columns and others, that will be difficult to use this kind of reality capture techniques. And the two, the number one and number two, they are usually used for cast-in-place activities. So based on those methods, if you look back to the previous research works in the progress monitoring field, there are the work that the research community has already done that could be categorized under several major groups. From management perspective, how they have shown the progress of work, whether they have shown the progress of work in percentage or in other formats. So some of the research work, they have shown the progress of the work by color codes. They use different colors, as you see in the figure. The red color like used for behind of the schedule, and the green color on the schedule, and so on. And the figure you see here, this is one of the research work done by a researcher, and they used augmented reality for this color coding. Same to that one, another type of showing the progress of work will be based on the counting the number of objects detected within the point clouds. So when, for example, if there is a steel building, and they will detect the number of the elements such as beam columns, and as per the numbers, they will count or they will measure the progress of the work in terms of the percentage. And lately, there is another research work. They have shown the progress of the work based on the elements. And they shown whether some type of the elements are ahead of schedule or behind of the schedules. So there are all of these research work. There might be some others, but usually these are the major groups that the research work have already, the research community they have worked in. As we mentioned, we cannot use like GPS and other for cast-in-place activities, but photogrammetry and laser scanning procedures, they will be used for data collecting for progress monitoring. But still, there are some problems with these methods as well. For example, they are using static data collection tools, and that's why we need several of or multiple of these tools to cover the entire project, to collect the data from the entire site. In addition to that one, these tools will be under influence of environmental factors. For example, like if you're using camera, they will be under influence of the shadow, and also there will be influence of the wind and sun rays in others also. So the progress of work, as we just mentioned in previous slides, they're also somehow they're not much in detail because they have shown only in progress, which we usually, if you look back to the invoice method in contracts, or when how the payment is done, that is need a detailed progress analysis. So that's why we can say even that will also not be helpful to practically use such methods. Anyway, we are going to, in this research work, to use a mobile scanner instead of the static laser scanners like GSLAM mobiles, and also to accurately measure work progress and in terms of percentage. And also, since we know that when we collect the scan data from construction site that has noise in it, and also there will be redundant elements within that one. So this is important to clean that data also and extract object of interest. The research methodology that we have provided for our search work, it has 3 stages. The first stage is related to digital twins. The second is related to progress analysis, and the third one goes to schedule updates. And digital twins, we have on the one side as design BIM model, which is already provided for the building and with different softwares, for example, Revit and others. And also on the other side, we have scan data from construction site collected by the devices. So if we have several of scan data, then we need to register them. If not, if there's one scan data, then that will be used directly in filtration. For filtration, from as design BIM model, we extract those elements that are under construction. For example, if the work is only for walls, then we extract the walls from as design models. And as per those elements, we will produce a benchmarking point cloud, which is a clean point cloud, and that will be used for filtration. And same to that one, from as design BIM model, we also filter the as planned model. This as planned model is a portion of as design BIM model, which is used for a portion of work for a specific time interval. So once we cleaned the data, filter the noise in redundant elements, then we will convert that one back to the BIM model. So, and we reach to the second phase of the methodology. So here in the second phase, we compare the as-built BIM model, which we created from a cleaned point cloud. And also we have the as-planned model, which we filtered from as-design model. And we compare these two models. Usually, this comparison is based on the quantity of material, and this analysis in 2 stages. One, it shows the status of activities as per the schedule in color codes, whether some part of the work is ahead of schedule or behind or on schedule. And the second stage, quantify the each element, and we measure the progress of the work in percentage. So that percentage which we get from this second phase or second stage, then that will be used later on in schedule updates for different in different software, for example, like in Primavera or in MS projects. So if we have only one cycle of the work, then that will be finished unless the same loop will be continually used until the end of the project. Here, since our benchmarking point cloud in the filtration is based on the as design BIM model, so the assumption is that the as design BIM model should be regularly updated as per the contract modification and change orders. If there is any change order in the contract, so we should be that will be reflected in the as design BIM model. As we mentioned before, the data filtration. The filtration is based on the benchmarking point cloud, and also we are using Hausdorff distance for filtration here. The benchmarking point cloud is a cleaned point cloud. It doesn't have any noise, and that is generated from as design BIM model, and we are using the Cloud Compare software for that one. And it doesn't have any noise, and just include the point cloud for object of interest only. And also we are using Hausdorff distance for to indicate the similarities between the 2 point clouds, because usually in engineering applications, the 2 point clouds, they will be not identical. So that's why it is needed to have the similarity between the 2 point clouds and not have like a one-to-one relationship. That's usually that will be difficult. So we have the mathematical equation for that one, and through that one we are calculating the deviation between the two models. So within those deviations, the less the deviation we have, the higher the similarity will be between the models. So once we apply the Hausdorff distance, through that one, we will get the similarity point clouds and will remove all others which are not included in both in both point clouds. They will be removed. Through this method, we can remove the noise, and also we can remove the redundant elements that we have either in benchmark point cloud or either in scan data from the site. We did our case study here at engineering building of UNSW, and that we used only a meeting room, which has also associated with that one a kitchen, and there are different furnitures and kitchen stuff. All of them we consider that one as noises. As you see, the top right figure, that is the point cloud we collected for the two rooms. The smaller room shows the kitchen area, and the lower we provided the BIM model as per the exact data from that room in the Revit. So it actually we to prove the methodology, we use this scan data from already as-built building. So here in this case study, we collected the data from the site. We used the handheld scanner, which is a mobile scanner that is easy to use, and also the scan rate will be around more than 43,000 bytes per second, and the accuracy will be 1 to 3 centimeters. It has some colors, as we just saw in previous slides, but the method in our methodology, we are not using the color of these point clouds in calculation. To further simulate the construction site, we only focus in this case study to the walls only, and we not consider other elements because the walls usually constructed on the construction site progressively, step by step. So that's why we also provided and considered different cases. For example, the first case is zero progress cases, means the work has not started. And we also cut the point cloud to the lower part of the windows on the south windows of the building. So we call that one like the second case, or case 2. And the third case, we consider the progress of work up to the lower part of the small windows on the west side of the building. And we consider that one the third case, which is also a partially completed work. And the fourth case is that completed the entire building, which all the walls are completed 100%. For that one, we cut these point clouds in to other levels, as we just mentioned. In the fourth case is that complete point cloud that we had here. That is the fourth case. As we mentioned before, that we used as-built benchmarking point cloud and filter the data. So the procedure here starts with first the creation of benchmarking point cloud for the walls, because the focus of this case study is only for the walls. So that's why we extract the walls from that BIM model, and we convert that one to a virtual point cloud. as you see here. Then these virtual point cloud will be registered with the site scan data, and we apply the Hausdorff distance. Application of the Hausdorff distance will be in MeshLab, which is an open source software, or we also can use the Open3D package in Python. Both will give the same result. With that one, we will remove some noises. And also, after that one, we apply the RunSock algorithm. Because some point is additional point like as noise will be included in the result of the Hausdorff distance, and with RunSock application we will remove that one and we will have a clean point cloud. So that clean point cloud finally will be converted back to as-built B model, and we used Autodesk Revit for conversion. The result is shown here. The part A shows the registration of benchmark point cloud with site scan data. The red color shows the benchmarking point clouds, which register it with site scan data. Once we apply the Hausdorff distance, we will reach to the part B. That is the result. We extract only the similarity, which shows the walls. Some parts, as you see here, like the corner of the here in this part, like the corner is not shown, or in these parts that we don't have. That is because in that areas we have furnitures, and also we have kitchen staffs. So that's why they will be not included, since we extract the similarity between the two point clouds, and those areas will be removed. And also, since we created the benchmark point cloud for the both sides, for all sides of the walls, like inner sides and outer sides of the wall, so that's why there will be some points remained in this result of Hausdorff distance, and we apply RunSock algorithm to remove those points, like as shown here with horizontally planes, and we remove them to reach and to have a further cleaner point cloud. And the result of that Hausdorff distance is shown in part D. So the same procedure, as we mentioned, we have two other cases in our case study to simulate further the progress of the work on the construction side. So that's why for part E in part F, which is case 2 in case 3, or scenario 2 or scenario 3 of the case study, we applied the same procedure and we have the clean point cloud. Then we used the Revit 2018, and we convert this one back to the BIM model. As you see here, G shows the case 2, which shows the progress of the work, the lower part of the west side of the building, and H has a higher level compared to case scenario 2, and I is a complete BIM model. Here, as you see in these BIM models, two walls on these corners we have in the point cloud, but we don't have it here because we removed these walls to show the status of activities later on. Because usually in construction site, there will be some activities ahead of the schedule and some activities will be behind of the schedule. So to simulate that scenario, we remove those walls here from as-built BIM model. The progress analysis, as we mentioned in our understanding methodology, it has two stages. First is color coding, and the other is progress percentage. This comparison is used in Revit, and we are using Dynamo. And within Dynamo, somehow we are also using Python code. And we apply the color codes as you see in this figure. So we have on the left side, we have the as-built BIM model. Only we shown this progress for case 4 for complete case. And we have as planned BIM model, the portion of from as design, which we have the plan to build that elements in a specific time interval. So we compare these two again to simulate like ahead of schedule and behind of the schedule. We don't have these walls in as planned model, but we have here in as built. On the other side, we don't have two walls here in as built, but we have them in as planned. It means those activities that we have in as planned, but we don't have in as built, they are behind of the schedule. And those shown here with red colors. And those activities that we have in as built, we have on the side, but we don't have in our plan. They are ahead of schedule, and that's not shown with color or shown with white color. And activities that are on the plan, and also we have built on the construction side, then they have shown with blue colors. So this is the first stage of progress analysis. In the second stage, we are using the quantities of these models to obtain the progress percentage. As we mentioned before, the procedure for measuring the percentage, we use again this Dynamo and also the Python code to obtain the quantities of each element, and we transfer that one to Excel sheet. And within that one, we simple proportion will be used to obtain the progress percentage. So how this procedure is working, we assign a unique ID of elements for each element. For example, for each element, we start from 100, 200, 300. And also we insert the as planned model in Revit, as a link model. And then we apply the color codes, and also we also take the quantities from that as planned model. And then we run the Dynamo program. Here just we have shown some figure of the nodes of the Dynamo program. The left side, which is a network, on the right side, some coding inside any node. With that one, when we transfer all the quantities back to an Excel sheet here, Excel sheet here work as a database, because all the data will be goes to Excel sheet, and there we compare the percentage, and back will be transferred to providing the updating the schedules. The idea we mentioned here, we have on the left side the activity IDs. Each wall we have assigned the activity IDs, and those coding will work as per these IDs, and they will identify each element based on the ID. We have the quantities of as built planned model taken from that element, and on the other side we have the quantities of each cases. As we mentioned, we simulated the construction site like to show the progressive work. We provided like 3 cases within this case study. Case 1, which shows no progress or no work on the construction site. Case 2 shows somehow progress on the work. In case 3, again, another like day 3, and case 4, which shows the completed work. And for all these cases, we have the volume of those BIM models. And then as per, we compared the as-built volumes with as-planned model, and we provided the progress of works here. Like for example, for wall ID number 300, we will have the progress of work on the wall like 34%, and then will be 50%, and then will be 97%, like that one. Again, since every work it has some errors, and this work will also will have some somehow errors. And if you see for case 4, the progress will be 97, 94, 93, and more than 100, like same to that one. The later BS and AS here shows the ahead of schedules and behind of the schedules. Here we just calculated the progress of the work for only activities that are inside both models that we have it them in as-planned model, and also we have them in as-built models. Then it needs to calculate the accuracy, because since there are some activities more than 100 and some less than 100. For that one, to calculate the accuracy of the work, we accepted the as-planned model for each case as 100% complete to further calculate the accuracy. And again, we done the progress of the work, and there will be less than 100 or more than 100. And for calculation the errors, we calculated the error in each cases. We just simply subtracting the progress of each case from 100 to show whether they are more than 100 or less than 100. And with that case, we are calculate the absolute value, and then the average absolute value, and then we calculated total average, and finally we will calculate the accuracy, which will be around 95%. It means 95% this method will work that to calculate the progress of the work. With that one, still, as we mentioned, we have still some, each research work will have some limitation, like that one, this case study in this work also, we will have some limitation also. And these limitations are like, the first step is like further cleaning of Hausdorff distance result with Transhoc algorithm, because we applied and showed that there are some points which also need it in the second step with Transhoc algorithm, and it needs in the future studies to remove this Transhoc algorithm in only in one step when we apply Hausdorff distance, and we get result as clean data. And for that one, we did in other case study, we extracted the benchmark point cloud only for inner side of the walls, because the point cloud is for inner side of the walls. Then we created the benchmark point cloud also for the inner side of the walls. When with that one, we will not be needed the Transhoc algorithm. Also, as we shown the status of activities with different colors, and as you see, for ahead of the schedule activities, we have not applied any color, and this is because the limitation of the Revit model, because we are not able to apply the or override the color to the Revit. That's why it seems with different color. It need also like to further to work in this area to show the model with different colors and to solve this issue. And also, since we use the handheld scanner, the errors from the scanner has not considered. This is our first case study, and we will consider later on once we finish some of the problem with our filtration procedure. And the progress, as we just saw, it was based on the activities on schedule activities only, and we will not consider the progress for ahead of schedule like that with white color. And since if we have the work on the construction site, either that is ahead of schedule or that is on schedule, both of them need to have a progress percentage. So it will also be solved later on with considering the quantities from as design model, not from as planned model. So with this one, my presentation finished here. I will be happy if there is any question and discussion regarding my work that will provide further insight to this research work. And thank you for your attention.
Thank you very much for your presentation. I guess Mudam is going to have quite a lot of questions, right, Mudam? It's very close to research that you are doing.
Yes. But it's a little bit different from my research because I didn't use the BIM 3D model. adjust the processing on the point cloud data rather than using some BIM model. So it's a really big difference.
A little bit different, yeah, indeed.
Yeah, actually, like here we are working from management perspective, like providing a general foundation, like how the data should be used to measure the progress. But mostly, I think Modern's work is for point cloud processing, not like from management perspective, I think.
That's true, yeah, but in a way you are also trying to obtain the as-built model to be able to compare with as-design.
Yeah.
So you're also doing point cloud processing,
yeah,
to be able to estimate what is the as-built model.
Yeah.
And actually, I was wondering exactly here, you don't try to identify objects, so individual walls or individual construction elements. You just compare the 2 point clouds, right?
Here, like what I got from your question, like first we registered the point clouds,
yeah,
and then we extracted the point cloud for the walls only, not from others, because in that site scan there will be everything included. But since the benchmark point cloud is only for walls, then the result will be only for walls, not for other elements. And then we convert back to the walls, and we compare the beam to beam model later on to show the states of activities and also to measure the progress percentage.
But the bench point cloud is created from the beam, right?
Yeah, that was created from as-designed beam model, yeah.
Yeah, exactly. So how did you create the point cloud? Was it on the basis of a mesh, or how did you do it?
Yeah, we use cloud compare software, and for extracting, as I mentioned before, in this case study, we considered only the walls, and we use an STL, convert that one to STL format. And as per the STL format, then we can convert the STL format to the point cloud in cloud compare software. But in the second case study that we are going to do it, since we extract only the inner surfaces of the wall, not the outer surface, because they are not included in the site scan. So we are using Dynamo to extract those surfaces. And again, we convert that one to STL format, and from STL, we convert that one directly to point cloud.
But how dense is the point cloud that you get from the as-design model, from the walls for the bench?
The density, it depends on this. There are different factors should be considered. Here, in the case study that we also are doing now, it is around, like if you say square meter, it is in thousands per square meter points, like because the denser we have the benchmark point cloud, the result of the house-to-house distance will be denser, and we have a cleaner, unless there will be a sparse point in the result of the house-to-house distance. So that's why the more denser we have, and the result will be better later on in house-to-house distance.
And do you have an idea how dense is the point cloud? How many points?
Not yet, because that is I'm working with that one. Because like in one of the case study when I was working, I provided with different density, like around 15,000 per square meter, and also 20,000 pint per square meters, and 10,000 pint per square meters. And then I look back to the result of that one. Still, I'm working with that one.
It's really very, very dense point cloud.
Yeah. Yeah, because it depends also the subject, the object of interest when we extract from the point cloud. For example, if the object of interest a bigger wall, like a wall with like 3 or 4 meter length and 2 or 3 meter height, then if we have less density, it will help to extract that point cloud. But if the size of the object is smaller, then we need like to have denser point cloud that will help further reducing the noise and also extracting that object.
Okay. Yeah. So you are actually only working with point clouds. You compare everything to point clouds and okay, you do the analysis, you decide which walls are constructed only on the basis of the point clouds.
Yeah, which wall is constructed, which wall is ahead of the schedule, which wall is on the schedule, and which was behind of the schedule, because we compare with as-planned model. And that color coding shows, as we see here, like will be used for managers and other stakeholders who don't need to have further insight in the progress, just to look which part of the project's ahead or behind. But to further shows like for the payments and for the resource allocation, then we need to have further detail of the work. And that's why we should have the quantity of these elements from as-planned model and as-built model. Then we calculate the progress work.
Yeah. And these models, how big are they? If you have such a high density of the point cloud, how big can you process one floor at once, or you have to cut it into pieces?
No, these are calculated at once. Like because the point cloud that we created, that we have in benchmark point cloud, although this like around more than 5,000 point cloud per square meters, the result of the Hausdorff distance will be a parse point cloud. It doesn't have the density as like the Hausdorffs, because once we apply that one, the result will be very sparse and will be a loose point cloud. So it will simplify the process of the work.
Yeah.
And for application of these color codes, we apply for all the elements. As I mentioned before, when we create the as-built BIM model, we assign the ID for each element, and the code will work on the based on the ID. It doesn't matter if we have one floor or two floor, since if there is ID, then they will generate this color code for all those elements.
Yeah. And now, do you assume that these are some kind of construction elements that if they're there, the whole element is there? What will happen if you have just, let's say, bricks, and for example, they finish only half of the wall? Is the algorithm going to recognize that half the wall is completed?
Exactly, like as you mentioned before, here in this case 2, like let's go back to these cases. Here I cut the case, the point cloud to these lower parts of the windows, which shows like, okay, the progress work onto the lower part of the window to the south side. And then the progress will be a bit higher around to the lower part of the west side. So like step-by-step progress of the brick wall. So yes, it can show, but here I didn't bring those cases in color codes. Just I shown with the case 4, but that can be shown here also with colors, and also in terms of progress percentage, since they work based on the quantities, and if any amount of quantities that we have, either that is half completed, or let's say, for example, 30% completed or 40% completed, then we can extract that quantity and we calculate the progress.
Yeah. Yeah, quite interesting indeed. Yeah.
One question.
Go ahead. Yeah, go ahead.
Because I have seen many papers on, they also use the laser scanning of photogrammetry, the point cloud for the progress monitoring. So I want to know how you identify your research contribution compared with the previous studies.
Yeah, look to in previous study, as I mentioned in my literature review, if you look back to the previous research works, there are different categories. Like they have shown the color codes, but that color code, like either they have used augmented reality. So augmented reality is different. What we have shown here, like we are using scan to beam, and we are using exact point cloud here. Sorry, exact the beam model, which can easily quantify that one. And we extract the quantities, and as per that quantities, we show the exact percentage of that one. And this will help on the one side to the cost of the project. On the other side, you know, when you're working on the construction side, resource allocation, either that is manpower or that's machinery, in others, even the procurement management is based on the quantity of material you're using on the construction side. So this will help in that area also. And the second thing, those research works, they have shown like percentage, but that percentage is based on the elements. Again, when like for example, they counted the elements on the point cloud, whether they detected like the number of beams, and they change that one to the percentage, which again, that will be not too much accurate when you're working with resource allocation and others. And the other types of the work in other research works, they have shown like ahead of schedule and behind of schedule in terms of the element. These have shown, okay, the walls are ahead of the schedule, and they shown the columns are behind of schedule like that one. But they are not in detail, like too much in shown in progress in percentage. That's the one thing. The second thing, cleaning the data and removing the noise in other elements, like redundant elements when you have the scan data from construction site. That's also very important to clean that data and extract only the elements that you want. As you know, the construction site will have different elements on the site. So that's why application of this host of distance is a new we say method that we can extract only the thing or elements that we want. This is the second. And also the third one could be using this handheld scanner. As you know, these photogrammetry methods and these terrestrial laser scanners, they when you cover a construction site to measure the progress, so you need to install several of them to cover the entire site, unless it will be difficult to understand the progress. So that's why using a mobile device compared to static will help a lot, because that will be simple and you can cover the entire site. And later on, such mobile devices will also help like to be installed on any robotic platform, which will not be needed for laborers to go to the construction site. And the robotic or the robots will go there, and they will collect this scan data, which we have different types of robot. Even they can climb up over the stairs. So that will provide the opportunity for such work. So that is the other issue which we can somehow solve the problem with photogrammetry in static or terrestrial laser scanners.
So you are more focusing on the perspective of the management in the real practice.
Exactly, like yeah, because we wanted to shorten this progress and to be accurately and timely calculate the progress of the work. Because usually in construction site, from my experience, there is always a claim between client and claim between contractor. Contractor always try to claim more work they have done to receive further money, but on the other side, clients, they want to pay less money to be assured that from contractor side that, okay, first do your work, then get your money. And also sometimes if there is a breach of contract between these two sides, in that area, and you wanted to reduce or resume your project again with new contractor, then such work also will help to scan the data and progress the measure exactly. Because I have seen different contractors, they have, when they provide the schedules, they front load the schedule. It means they will provide much money for the works. For example, the foundation will be first. They will provide higher amount of money for the foundation. Or let's say if the foundation is X amount, they will be providing X plus 1 to that amount. Like they will provide much more money. In case there is breach of contract with that contractor, then the client will that will be a problem for the client. So this kind of work to accurately measure the work, then such issue will be resolved, and also the claim between the contractor and client also will be solved.
You collect data from the real construction site and see how you proposed proposed method can be used in the real practice where you try this way.
Yeah.
So your next step will be the implementation of your method in the real project.
Exactly. We want to use not only with actual projects, but also we are trying to apply this one in further steps. Like there are like cost or resource loading. Apply that one. How this will help, like a resource allocation, like machinery, also the stockpiles or the procurement. Because usually when you have the work on the construction side going on, so we need to have material management for that one. So we will look also to other side of this one, how this will work to procurement management, because that's very essential and that affect the successful completion of the project. If we have a work ahead of the schedule and we don't have on the other side material for that one, then there will be a delay on the work. And same to that one, if there is a delay on the construction site and we have additional material, that will not help on the construction site. So different issue will happen. So we will look also to the resource allocation, or we will look to the other aspects, as you mentioned.
Okay, thank you. Very nice presentation.
Thank you too.
Yeah, indeed, very interesting presentation. Do we have more questions?
Yeah, I want to ask one. Yeah.
Yes.
Thank you, Mohammed. That was nice presentation. It is very interesting when I see researchers doing something with point clouds. I understood that you are more interested in the management part, which is interesting. The only concern that I have is that you're kind of using a lot of software.
Yeah.
And if you want to do kind of real-time processing or like showing the results that you achieved here, I think it will take a lot of time, because you need to open this software, that software, and why don't you try to do everything, let's say, in Python and compare the points? There are some interesting libraries there. You mentioned some. And I think you can achieve more towards real-time processing and management.
Exactly, as you mentioned, that's a good question. As you saw that the time we have mentioned real time. There are two issues. One, interoperability of the software that will cause a problem, but later on that problem could be solved easily, because that is a matter of software engineering. And if you can solve this issue with mesh lab, with a translocal algorithm, and with host of distance from other software, then with software engineers, we can provide a platform easily, which will same work like a Python. But anyway, since, as I mentioned before, we are going to provide a general foundation for our work from management perspective of the work, then still there are some other issues. Like, for example, we have used scan to BIM work here. We converted that point cloud back to the BIM model, which is usually scan to BIM is semi-automated in some parts. In some parts, that's a manually process. Not we are not able like to completely do it, but that's another issue. Still, we are working with that one. The idea you have mentioned, we will say that we can do that one with Python, like converting, but it will also, since we have some open source softwares, to focus more on our work rather than from software perspective. So we use these softwares. Like the focus is more in our work, not like to reduce the time, because as we discussed with the supervisors, and we have the idea that, okay, once we have proved our methodology and it's working, then matter of reducing the time and those softwares, bring them to one platform, that will be a software engineering issue. It will be solved easily.
Yeah. Well, definitely it is possible. I'm not sure if it is easily solvable, but what I was thinking maybe to have another approach, which is more kind of practical, and solve it maybe in a bit different way, but to use one technology.
Yeah, that's a good idea. Like,
yeah,
it's
kind of to try to solve it
consider that one. Yeah.
only with Python, let's say.
Yeah.
Yeah.
That's a good
because
idea.
To me, I think you're a bit overcomplicating with using too many software, and I'm not sure that this is really needed. I think if you just a bit rethink the methodology, I think you will find another solution, which is maybe more practical and maybe more real.
Yeah, I will look to that one. That's a good point. And yeah.
Thank you.
Okay. Okay, do we have more questions? Okay. Then Jack, back to you.
Okay, well, thanks very much, Mohammed, and a round of applause from everyone.
Thank you. Thank you.
Yeah, and best of luck with the progress for your work. We'll be in touch with what we've got planned for the next few presentations in the next few weeks. So just keep an eye on your calendars. So yeah, thank you very much, and I'll send you the YouTube link, Mohammed.
Okay, thank you. Thank you for your attention.
Thank you. Okay, cheers.
Bye.
Thanks, everyone. Bye.
Bye.
Yeah.